today we will start with the basic threading concepts and the basic way of creating a thread. So before we dive into code, let's check out the documentation for Python and see what we have there to get started with threading. Alright. I'm gonna switch to my browser, and if you go to docs.python.org/library, you will find the list of modules, different parts of the standard library. One of them is threading or multi-threading, something like that. If you search for it, you will find there's a section, concurrent execution. And under this section, we have several other topics like threading, multiprocessing, multiprocessing.shared memory, and concurrent package, concurrent futures, subprocess, SCAD for event scheduler, queue, and so on and so forth. So you can see that it's a huge topic. Threading and running multiprocessing is a huge topic. And if you have studied computer science in college, or you have read some computer science books, you have seen that, especially OS books, operating system books like Tannenbaum's operating system for Linux, you will see that there's a lot of talk, a lot of concepts in terms of processes, threading and managing them, also scheduling between them, and concurrent execution. But in this section, in this video, I will only talk about threading, the basic one, the basic way of creating threads. So let's open concurrent execution. You can see that there are different topics and titles here. Under threading, we have thread local data, thread objects, log objects, rlog objects, condition objects, semaphore objects, event objects, timer objects, barrier objects, and using logs, conditions, and semaphores with the wait objects. Only under threading we see a lot of different concepts. So I'm going to cover only a bit of this topic, a bit of the subtopics of threading, which is thread objects. And what is a thread object? A thread object is in fact an object that allows us to run an activity in a separate thread of control. Allows you to define a function that will be run in a different thread of control, so that you don't have to wait for it to be done when you are running your code. You can ask it to be performed, to be executed in the background, and you are doing your work. So I'm gonna show you the different ways that you can use threads and create threads. In fact, we have a class called thread with capital T from the threading module. And also there are several useful methods that you can use from the threading module itself, like getIdent to return the identifier for a given thread, and getNativeID to get the native ID for a given thread, and also enumerate, I'm not sure what it is for, main thread that returns the main thread that started the Python interpreter. It will return something like main, underline, underline, main, underline, underline. And other methods that you might find useful here from this module. But actually, let's go ahead and talk about, okay, the stream is good, sorry for the hesitation. I'm gonna switch over to Visual Studio Code without any further loss of time. Let's switch to Visual Studio Code. There we go. Visual Studio Code. I have been working on an example, but I'm gonna start from scratch actually. So I'm gonna remove this part, the console, and I'm gonna also increase the size of the font a little bit. I'm going to create a file called zomcast threads.py. And as I said, the module that we will be working with is threading. So I'm going to import threading. So basically there are, as I mentioned, two ways of creating a thread. Both of them use the thread objects. So I'm going to show you the first one, the easier one. First, we will need a callable, a function that will perform that job that we are looking to do. So I create a callable, I name it job, def job, and inside it I create a print statement. I call a print statement started job, and I do a timestamp here. I print the timestamp. I need the time module for that, so I import it. Time. It's useful to know what time the thread started execution and what time it finished. And then imagine we are going to perform some job that will take about 3 seconds. So I'm gonna say while. So let's save actually the initial time. So start time, I'm gonna save it in time. I'm gonna say catch it with time.time and then save it in start time, and then while time.time minus start time is bigger than 3, then print this, print performing job, and then waiting a little bit, waiting for about 1 second. So time.sleep, I can use time.sleep for that, and I can say 1 second, for example, wait 1 second, and once you finished it, print that as a notice, finished job, time.time again. Also, when the job is being started, you can use the useful function from the threading module getIdent to see what thread is actually doing this. So we can say print this as well, threading dot get ident, and here as well threading dot get ident time.time. This is our actual job, but how do we create a thread out of it? As I mentioned, there are two ways. So the first method, first thread making way, it is by calling threading.thread and then passing in your callable. Here our callable is job. So I'm gonna create my first thread like this, thread 1. Actually, let's use the numerical one and then thread. We are constructing a thread and we are passing in our job. Which parameter should be passed in as? What parameter should our callable be passed in as? It should be passed in as target. So if you look at the list of the parameters for thread, you will see that one of them is target. So as target, we are passing job. Okay, we have one thread. But what is the second way of creating thread? I'm gonna show you that as well. Second thread making way, and that is actually by subclassing the thread class, by which I mean I will create a child of the thread class, and I do that like this: class my thread extend from or extend threading.thread, create a child from the thread class, from Python's thread class. And then there are two methods that you will need to override. One of them is the constructor. So def init self, and we construct it like this: super dot init. We must call init on it. Okay. And the other very important function that we will need to override is the run method. So def run, it actually defines the actual function that we will need to do. Therefore, I will need to use the content of the job function inside run. So I copy all the content of job here, and I put it on the run. I put it on the run. Let's add some indent. Come on, don't be stupid. Needs to be indented to the right. Okay, def run, and then it has to have self keyword here because it's part of the class. And you can see it's doing the same thing that the job function did. Our activity, it's printing starting job when it enters execution, and then it records the start time, does its job, and then prints finished job after the job is done, aligned with its identifier and the time that the job finished. Okay, so I showed you just how to make threads in two ways. One of them was by passing in your callable to the thread class and creating an instance of the thread class, and the other was creating a class of your own by subclassing the thread class and overriding two methods, the init method and the run method. Sorry, I have done a stupid indentation mistake here. I don't know why Visual Studio Code indentation keyboard shortcut doesn't work by pressing Control and left curly brace on keyboard. So I have to do it manually. Move this a little bit to the left, and all the functions, all the content of it also to the left a little bit. Let's see if I can do it by dragging with mouse. Okay, it's not a big deal. It will run anyways because it's under run and it has some indentation, sorry. So we had one thread object called thread1 that was created using our first way of creating thread, and the second one will be an instance of my thread that has been constructed using the second way of creating threads. So thread 2 is from my thread, and it doesn't take any parameters because it already has everything it needs inside it, defined inside its constructor and its run method especially. Okay, now it's experiment time, it's run time. We must see what is going on and how it works. Let's run it by seeing what it does. First, I say print before running thread, or our normal code, inside our normal code. And also let's record time here, and also let's record the identification, that the thread identifier of the main thread that we are running our code in. So threading dot get ident And then let's run our thread 1.start. By calling start, we are actually running our thread. And then let's record time after the call to our thread. So print after starting thread. And by the way, you know that the thread will take 3 seconds to finish because it has in its definition. And then threading.get ident. Both of these identifiers will be the same because they are called from the same thread, the main thread from our code. And the time. Okay, let's run our code and see how it works. Let's clear the console and then run Python interpreter and zomcast threads. There we go. What happened? Before started job, before running thread, the time, you can see that the identifier is here, 6528. After starting thread, 52. And the thread that was run has a different identifier. You can see it is 2512. And after it's finished job is printing finished job, but the time is the same. The time is the same, so it didn't take 3 seconds. Something is missing. We have some problem in our code. While the time plus 3. Oh, plus 3 less than 3. Yeah, while it is less than 3, we should run it, and after that the time offset will be more than 3 seconds. Therefore the execution will stop after 3 seconds. But otherwise it was wrong. This condition was more than 3, and every time it was more than 3 actually. Was it more than 3? Minus start time. More than 3. For example, it was 10. This was 10. The current time and the start time was 2. 10 minus 2 equals 8, and it will not run. The first time it is less than, okay, time, if this is 10 and this is 10, this the result becomes 0, and 0 is less than 3, so this will run. But if this is bigger, then 0 is not more than 3, therefore it will not run. Okay, this time it will run correctly. There we go. Performing job, and there we go. After the job is finished, you can see that the time is 42:94, and it was 91. It started at 91. You can see it started at 42:91, and we don't care about the decimal parts. These are the smaller units of time that our machine supports, but we are happy with the seconds part only. 42. It started at 42:91, and it continued for 3 seconds, 42:94. And you can see that we had 2 threads running. Why? Because we have their identifiers. We have the identifier of one of them, that is 51:52, before running the thread, 91:68, and the other 51:52. 91:68, and the main thread is 91:60. Yeah, The main one is 51, sorry, is 9168. Alright. After starting the thread, you might ask yourself why this statement is printing here just after the call to the thread and not after it is finished. We know that our thread took 3 seconds to execute and to finish execution, but the call to after starting thread, the result of calling this has been printed just right after calling the thread, after starting the thread. You can look at the timestamp and you can see that 4291 is started at 4291, and our main thread has printed 4291 at 4291. It is exactly almost the same time, almost at the same time. Why is that? You might ask yourself. The answer is that the thread is being executed in a separate control, in a separate unit of control, and you don't have to wait for it to complete. Therefore, you are doing some kind of parallel processing. So this thread is started and doing its job, and our main thread is executing its other lines of code. So it is not waiting for the started thread to do its job and then join it. But what if you want it to happen? Actually, you want to join the thread that executed. You want the thread that executed to join our main thread, and then we continue our code. There's a way for it, and that is actually by calling a method called join on our thread object. And actually it is this way. We can say threading.join, thread1.join. We call this, and then the thread will take its time, process its do its processing, do its job, do its tasks, and after it's done, then the control will be back to our main code, and our main code will continue its execution. So if we run it again in a separate console, let's maximize a little bit this part for the console, and if I run it again, zomcast, you can see performing job, and yeah, there we go. In the previous case, this method, this output was printed right here after printing started job, because we didn't wait for the thread to finish and then we printed this. But now we are actually waiting for that thread to finish its job and then join us, and then we are printing this output. And you can again see that we have two distinct threads. One of them is our main thread in which we are running our code. It is 2032, and the other one is 8016. And each time that you are running your script, these identifiers change actually, because if you look at our previous output, it was a different thing, 2032 in this, and 6528 in the previous output. So they are different. Each time you run your script, the thread identifiers that are allocated for your threads will be different from the previous run, and that's natural and expected. Alright, that's it for a basic way of creating threads. We didn't do anything useful inside our thread run method, but you can do something more useful. For example, here as we are running in the background, you might do some network request, or you might do some, actually network request probably is not very useful here, because after doing the network request, probably you need a mechanism to signal the other thread. But anyways, you might do some background job like zipping a file, creating a zip file, compressing a file, or decoding a bitmap or something, and even the network request, getting the output from getting a resource from a remote location and then decoding it, doing some operation on it, and then finishing the thread. And then if you are using join, your main thread can make use of it, and so on and so forth. This was a very basic example of threading and how to use threads. It's not all about threading. It can be it can take more to talk about threads, and as I mentioned, threading is a big topic, and we will continue our talk about threads in the upcoming weeks. We will talk about other concepts in threading, like the locks, condition objects, semaphores, event objects, timers, and probably we will continue our journey in multiprocessing in Python to include other topics like multiprocessing, references, and so on and so forth. Yeah, we can continue our discussion. And there's an interesting package I love, the concurrent package and the executor objects, and also a sched object that allows you to do event scheduling, to run a special runnable or thread or process at a specific time in future, for example, to run it at a certain time. All right, and that's it for coding section this week. Now I'm gonna switch back to my cover of the week. Code Zombie, Zomcast 20, it's 30, it's 30 this week. Zomcast 30, I love it. And let's see what updates and news we had this week. There was, as I mentioned in the previous week, last week we had the opportunity to use the Red Hat's DevNation class that allowed us to use a personalized cluster, OpenShift cluster, for a whole week. Unfortunately, I was too busy to take the whole course, and I didn't finish it in time, and I lost access to the cluster, and it was one of the saddest things that happened to me. Okay, seems like my stream is having problems and it's really bad. Okay, let's pause the video for now. Okay, hopefully now the connection will be better, and the YouTube will not complain about my bad connection anymore. Okay, don't end it, please, dear YouTube. Don't end my stream. So I was supposed to talk about the latest development and updates in the technology. Oh, love Android. Android 12 developer preview 2 is available, guys. So you can go ahead and check out the developer.android.com website and see what Android has in store for you, Android 12, with its updated APIs and so on and so forth. And Android Dev Challenge continues. You can take part in the Android Dev Challenge with the updated Jetpack Compose challenge that challenges your ability to create creative UIs with the specification that the challenge defines for you for different UIs and designs to win a Google Pixel 5 phone. And this is only one of the prizes, I guess, and there are other different prizes. And announcing Kotlin symbol processing in alpha. So Kotlin symbol processing is a piece of software is being available, and I'm not sure what it is because it's in alpha and I had never heard of it before. I just saw that news myself. If anyone knows about it, please leave a comment down this video, and we will all be grateful to you. And finally, Android's dependency injection library Health reaches beta, and it's amazing. So now you will be having an experience of a beta and feature complete library for managing dependencies of your Android application. And That's it for Android side of the week. And now let's talk a little bit about GitHub. GitHub in Focus finished, and it was 3 weeks of content streaming. And unfortunately, for some reason, I didn't receive the email, or I missed it, and I missed the event. But if you are like me and you missed the event, and you missed the different sessions for actions, GitHub actions, DevOps, and so on and so forth, and the latest technologies of GitHub, don't worry, because you will still have access to the recordings from the InFocus 2021, and as GitHub claims, it will be available for you on demand. These recordings will be available anytime, anywhere. So don't worry, just go ahead and search it on your favorite search engine for GitHub in Focus, and probably you will easily find the latest recordings that are on demand for InFocus 2021. Alright, I hope that you liked this week of zomcast 30. Sorry, I'm making this mistake a million times. And see you in the next week. Please, if you like the video, leave a like, a comment, and subscribe to my channel. Take care and see you in the next week.